Subunit 2.2, the roles and challenges of teamwork. So a major difference between the university and the work world is a transition from where most of the work is done as an individual to where you have to work more and more as teams. Also a transition between well-defined problems with really strict boundaries to a world where there's a lot of ill-defined and ambiguous problems that need to be solved. What you see here is a picture of the James Webb Space Telescope team, and it gives you an idea. This is only the portion of the team that works at Goddard Space Flight Center. Again, this is one of those very diverse groups with people spread out all over the world helping build this telescope. What you see behind it is a full-scale mock-up of the James Webb Telescope. And what you see, again, is just the team members from Goddard. And you can see how many people that you have to coordinate their activities to build that telescope just at one of the locations where work is being done. And think of these team maybe multiplied by 3 or 4 or 5 times as you look at the rest of the James Webb team members that are spread out around the world. So you can see a significant number of people have to come together to solve this kind of problems. Systems engineering relies on teamwork. You have to coordinate a lot of people. You've got to bring them together to achieve the goal of building your system to get it operational. So you have all these big multidisciplinary teams. They use a lot of phrases you'll hear that describe those teams: an integrated product team, an IPT, an integrated product development team, IPDT. There'll be a lot of terms that'll be used to say, how do we bring together a large team to achieve a common goal and to develop a system? And these team and how you put that team together and how you organize and manage that team is a system engineer's most powerful tool. So multidisciplinary teams will include all kinds of specific experts in different areas. And so there's some examples here for space applications. You're going to have thermal control experts, electrical system experts, propulsion experts. That'll all be on the team. And in each area, they want to do their best to make sure that their components and subsystems will come together to help you achieve your goal. But it really relies then on a system engineer or system engineering group to manage that effort and, again, look over the top of it to make sure that all those disciplines have the right set of requirements to build their components and subsystems to, and then that they can all plug together in the end to achieve the team's common goal of developing an operational system. So there are a lot of reasons why we have multidisciplinary teams, and it's kind of obvious, right, that no one individual, imagine one person trying to design and build the James Webb Space Telescope, be a little bit of a challenge. So knowing that you have people with different backgrounds and expertise that could all come together is going to be a requirement for building a large system. But by having these big multidisciplinary teams, you're going to have fewer problems also in transitioning between the initial designing and engineering to building the system and operating it, because you've got all these different disciplines involved all along the way. So people who are going to do operations are involved early in the design process so they can help you understand design implications that might show up later when you try to operate that system. So you can maybe take that into consideration. Having this big multidisciplinary team also reduces engineering time by making sure that everyone is focused on solving their individual problems. And it can identify and resolve technical subsystem conflicts early by having all these different people with their expertise to bring to the problem. But diverse team interaction, it will help you in many ways by encouraging ingenuity, creativity, and also lead to challenges in trying to bring them together to a common goal. So some of the challenges involved in developing a team could include that team members are dispersed geographically. They're around the world, different locations, and they have to be able to coordinate their activities remotely. They might have different cultural basis. They just come from different backgrounds and different ways of looking at a problem and solving problems. And they might possess different kinds of process approaches. When you're working with large, diverse teams, people have learned system engineering in different ways and learned how to do problem solving in different ways. And again, you have to bring that all together.
I think the most challenging aspect of our diverse team is that we're spread all over the world. And so making sure that people can communicate well with each other is a huge challenge. We partially solve this with regular events, teleconferences, visits. We have contracts, we have grants, we have organizations of everything, we have document systems. So it all has to be managed so that people really do talk to each other when they need to.
Well, in terms of getting our prime contractors, Northrop, and our U.S. contractors to work with the Europeans, that's done in the context where NASA is the lead for systems. So we're in a good position to be natural ambassadors between the internationals and the U.S. contractors.
One of the great challenges of systems engineering is to make sure that everybody doesn't have to talk to everybody, so that the requirements that we're trying to meet have been agreed to and divided into parts which individual human beings can work on, so we don't have to all work on everything at once.
Well, it turns out that the diverse team works fairly well together, and so the challenges are not as big as you might think. The engineers really work well together, and the majority of the team is very experienced engineers. The two areas that end up being, kind of a challenge to some extent deal with the ITAR, the International Trade and Arms Regulation rules that we have to live into, and the proprietary rules that we have to follow amongst different contractors. And finally, the fact that the diverse team has diverse engineering processes. But you'd be surprised how similar most of those processes are. They really aren't that diverse, and we really have found that it's not as challenging as you may have first thought. But the working within ITAR is one thing that a lot of engineers, including myself, have to really stay conscious of. But other than that, the diverse team has worked well together.
Now click on the icon to read a short paper from the Jet Propulsion Laboratory entitled, "If You Want Good Systems Engineers, Sometimes You Have to Grow Your Own."